So now let's look at rates of change in polynomial functions. So recall that a secant line is a straight line joining 2 points on a function. This line hits 2 points on this parabola and is considered a secant line. The slope of a secant line is equivalent to the average rate of change. Next is our tangent line. A tangent line is a straight line that touches the function at only 1 point. So here the line hits the parabola at 1 point. And the slope of a tangent line is equivalent to the instantaneous rate of change. So consider the graph showing the salmon's height in centimeters relative to the surface of the water. On which intervals will the slope of the tangents be positive, negative, or 0? The slope of the tangent will be positive from 0 all the way up to x equals 1, and then from x equals 1 all the way up to our first turning point, which we will identify as x equals a. The slopes of the tangent will also be positive from our second turning point all the way up to x equals 6. And we'll identify our second turning point by the value x equals b. Therefore, the slope of the tangent is positive on the following intervals. We can also see that the slopes or tangents are negative from a to b and from x equals 6 and onwards. And finally, the slope of the tangent would be equal at x equals 1, at x equals a, at x equals b, and at x equals 6. So what do these slopes tell you about the height of the salmon? Well, a positive slope means that the salmon's height is increasing. A negative slope means that the salmon's height is decreasing. And a zero slope means that the salmon's height is transitioning from increasing to decreasing, or vice versa. Determine an equation for the height of the salmon, h at t, with respect to time. We have a 0 t1 at 1 second, which is of order 3. We have a second 0 at 4 seconds, which is of order 1, and a third 0 at 6 seconds, which is of order 2. So this means our equation looks like the following. h of t is equal to a, t minus 1 cubed, t minus 4, and t minus 6 squared. Next, we need a point from the curve. And in our diagram, we see we have the point 5 and negative 64. If we put that into our equation, we get negative 64 is equal to a, 5 minus 1 is 4, 5 minus 4 is 1, and 5 minus 6 is negative 1. So taking the 4 cubed times 1 times negative 1 squared will give us positive 64. And dividing both sides by 64 gives us an a value of negative 1. So therefore, our height function with respect to time is equal to negative t minus 1 cubed times t minus 4 times t minus 6 squared. Determine the average velocity for the interval 0 to 1. So if we want to find the average velocity, that is just delta h over delta t, the change in height divided by the change in time, which is h1 minus h of 0 over 1 minus 0. h of 1 is going to give us negative, if we sub in 1 into our equation, 1 minus 1 is 0, so that's 0 cubed. 1 minus 4 is negative 3. And 1 minus 6 is negative 5. And remember, we need to square that one. But since we're multiplying by 0, we get h of 1 is equal to 0. Next is h of 0. H of 0 is going to give us negative of negative 1 cubed times negative 4 times negative 6 squared. And if we multiply all those factors, we end up with negative 144. So this gives us 0 minus negative 144 all over 1 minus 0, which tells us that our average rate of change is 144 centimeters per second. Finally, let's take a look at the velocity or the instantaneous rate of change at t equals 1. So starting with our intervals, I'm going to choose from the right side. So that's t going from 1 to 1.1, then going from 1 to 1.01, and then finally 1 to 1.001. 1.1 minus 1 is going to give us a delta t of 0.1. 1.01 minus 1 gives us decimal 0.1, and 1.001 gives us decimal 0.001. Next, we need to determine h of 1.1 minus h of 1. And if you use your calculator, you should end up with decimal 0.69629. Next, we need h of 1.01 minus h of 1. And again, using my calculator, I ended up with decimal 0.000744451. And for the final interval, I ended up with decimal 0.00000074945. If we take the delta h and divide it by delta t, for our first interval, we end up with decimal 69629. Then we end up with decimal 0.0074451. And then we end up with decimal 0.000744945. And you can see that the delta h over delta t is starting to approach the number 0. So at t equals 1, our instantaneous velocity is 0 meters per second. So again, the instantaneous velocity at 1 second is approximately 0 centimeters per second. And we can verify this from our graph. From our graph, we can see at x equals 1 that the slope of the tangents will approach 0 as we get closer and closer to 1.